Ansley?
Hi, Ansley.
That's pretty awesome.
Bye.
Alright, so Ansley, I forgot to start recording at the beginning, but here we go. So we're looking at this one. And we know because the degree of the numerator is greater than the degree of the denominator, that indicates slant asymptote. So we talked about the domain. The excluded value for x is 2, so we exclude that from the domain. Now, because this x minus 2 is both a factor of the numerator and denominator, it is a whole, so we do not have the vertical asymptote, nor do we have a horizontal asymptote. And then we found the slant asymptote by just thinking of division this way and letting those factors cancel, and that gave us the x minus 4. But we would get the same thing if we did the synthetic. We would get the same thing if we did long division. Yes? We do not have a vertical because right here where we were thinking vertical, that factor canceled and created a whole. Which means instead of the end behaviors, instead of going opposite directions, they're coming together right there. That's why it's a whole and not an asymptote. Okay. What other information do we need?
The whole is
-0.
-2.
Okay. You want to figure out what y is at the whole. I want to do that when I graph. We can think about the limit as it approaches 2 from either side. But when we look at the graph, it actually makes that a little easier. What about zeros?
X minus 2.
X equals 4. Why is 2 not 1? Because it's an excluded value. X cannot be 2. So it can't be 2 can't be a 0. Alright, what about a y-intercept?
-4.
-4. Alright, a sign chart.
Values.
Okay. What goes on my sign chart? Zeros and vertical asymptotes. So it's just 4. Okay. So if I tried 0, I get a negative, a negative, and a negative. Negative. And if I try positive, I get positive, a positive, a positive. I get positive. Are we good with that?
Why did you plug it into all 3? You can just plug it into the
You
next
could.
4.
Oh.
Okay.
What?
It does. All right. So let's graph what we know. We got one here at 4. We got one down here. -4.
All in 2.
Wait, so is it? So it wouldn't be an asymptote, it would just be the line.
Wait.
But like with a whole.
Wow.
Whoa, this is confusing.
Okay. Let's put on my slant asymptote.
But is it an asymptote or is it a line?
It's just the line.
So it's not asymptote is the line?
This is tricky.
Yeah.
Tricky.
So line can be on an asymptote now? That's a bit.
All right. So there's our slant asymptote.
No.
It's not okay. But it's all right. Okay. And we know there's a hole at 2. But why is it there?
-2.
Oh.
Wait, what?
And the weird part is the actual function
Is
the asymptote.
So it's not
Then why is there a
asymptote
hole?
because it's touching.
Oh, so it's just.
Wait, so then is that considered the asymptote or the function?
Is it exactly the
Because
asymptote?
you can't touch an
The one with the
asymptote.
hole.
Oh, I didn't mean for that to happen.
Control Z, Control Z, Control Z.
Guys, you have got to hush.
So then were we wrong and that wasn't the slant asymptote? That was just the
And
function?
that is what I'd like you to research.
Oh,
Okay.
no.
Don't
Well,
try to
no.
ask me questions.
No, it can't be all the asymptotes.
Okay, Don,
so
you
this is
gotta be
done.
quiet now, because that is your assignment. Okay, I give up. Your assignment is to discover, is this truly an asymptote? Is it not an asymptote? Is the function really a line? Is it not a line? One way you can verify is this the right function is just looking at your calculator. Pull out that calculator and see if, did we graph it right? Does it make sense? Because this is negative on this side and positive on this side. We can just count our slope to find that y value. What was our definition of an asymptote? Does this make sense with that?
It approaches but never touches. But this
No,
Oh,
it bends around it, kind of.
So does it like,
Okay.
So it's not.
So,
it's just
this is our first unique example today.
So it's 3D. It's hovering over the line.
So like
It's
It's not perfect.
another dimension?
Okay,
point on that.
so if you guys will write up for me what you discover when you actually look this up and not like just your opinion.
I
I'm
have
staring at
a
the-
scientific
i-
explanation.
it's possible that you could earn some extra points.
Wait, what are the questions we find?
Don't like
Okay, so is this function riding along the asymptote? Is that function on the asymptote? Does the asymptote exist?
You're going too bad.
What's the name?
Okay, so in just this specific type of problem. Okay, so you can't ask me anymore. And I'll take those write-ups tomorrow.
what was the last question? Do you want us to write for?
Huh?
How much do you want to sleep?
Just the answer.
Your extra points will depend on how well you've answered this question.
Want us to
No,
write?
So,
all
Alright, so I said, does the asymptote exist?
Miss Bailey,
Yes.
may I take a picture?
Okay.
May I take a
That
picture?
is kind
Yeah.
of what? How? So you
Does the
have
function
straight line. Riding
Follow the asymptote?
You have the straight line x minus 4
Yes.
over 1 y equals that. And then you multiply the top.
Approach?
By x
Right
minus
along.
2. All you did was just.
Right along.
Restriction, even
And the other one was what?
On top of?
Maybe we just
Look, if you
wrote
plug in
the,
points
we wrote
for
it
asymptote,
wrong.
you get the same
No, we
points.
didn't write it wrong.
Did we graph it correctly?
Probably not.
Okay.
We did.
So, does this follow our definition of an asymptote?
No.
No.
Okay. So, just writing the word no will get you no points.
Oh.
No, we have to explain.
You have to explain.
Follow
The
it.
explanation,
All these questions.
if valid, will earn you some.
What's the,
So it's just
what's the
all
problem
no.
again?
Math does not
Extra my
exist.
success.
So you're explaining, is this right? And if it is, why?
Can I take a picture of
Or is
that?
this
So
wrong?
that way I make sure I answer all the questions.
And if it is, why?
What's, okay.
Because it's graphic.
I'm gonna actually type it up because like.
You did. Kyle.
Is it because
Kyle,
you just get rid of
Because I
the
can match this on it.
If I answer your question, then I eliminate the option of extra credit.
Alright, then I'll.
Same.
That's why I'm not answering.
Well, no, because
Just
like.
asking. I'm only asking, Dalton.
if
I
it's-
am not answering. I will
No,
not
I know,
validate your
I'm
thoughts.
just telling you things. So,
And I'm just ignoring you.
coming from my.
But I
we're not
will
being mean, right?
read your solution tomorrow. And if I deem it the best, I'll read it out loud to others.
I'm gonna write a thesis about
I'm not gonna type it though.
I'm gonna have to type, I just
Oh, what is the equation? This
Fine, I'll
was the
type
equation.
mine. Is that what you want?
Okay, now, is this unique to this one problem I created?
No.
No, it's not unique, but it is a unique situation. Or is it?
No.
One the background.
Or yes, it is a unique situation.
It's when the part on the bottom is only a factor of the top.
Oh, no, wait, no, it's not, because
Oh
you
my
can
God, Dalton.
take, you can take like a quadratic
Okay.
Tomorrow.
and multiply the top and bottom by the same thing, and then it would just be a parabola.
If the bottom was.
Okay.
Oh my gosh, Ben's onto something.
Alright,
If you eliminate the bottom, then there's,
Yeah, you
then
can
it's
just
just a
eliminate the
line.
bottom, so all that's left is just that X mark.
alright, so if Ben shares his answer with everyone else, what happens to our opportunity for extra credit?
You'll get it.
I hate you.
No, but nobody,
I will.
nobody would get it.
Ben, you're right,
And-
but be quiet.
He might be on the right path, but he's not there.
You're not,
Yeah.
you shouldn't give me half your points, Carson.
Alright,
No.
so here's our second example of the day. And this one is also a little unique. A little different.
Oh, because
It-
there's more than a one difference.
It is.
It's
I don't know.
So it is. If this sign was negative, or this actually if this sign was negative, it'd be a little more exciting. But it's not.
Oh, wait, can't you rearrange it to where it's x cubed minus, or no, plus one?
What's unique about
And
it?
it's not
Minus
helping.
3x squared plus 3 factored by cube 3.
Nope.
Would we?
This only having one negative blows that opportunity. If there was another negative somewhere, we
Oh no,
might
you
could
can,
work that.
hold on.
It looks like this, but
Bro, it doesn't look like that.
it looks
I'm
like
right.
It doesn't look like
Yes.
that.
Would we do synthetic?
Could we do synthetic division?
What would it help?
Certainly. It actually at some point could be used and is necessary. Let's go through what we can do with this one. Everything we already know.
Domain.
Everything except one.
We know the domain can't be 1.
Yeah.
Oh, well, an x value of 1 is not included in the domain. Okay.
Are you going to?
Now, we just talked about how this doesn't factor to this, and we know because of the sign, so that didn't happen. Pascal's helps us with that, right?
Yeah.
We know that cube would give us the
That's the one.
1, 3, 3, 1, but the signs are not cooperating, so that doesn't help us. All right, what's next after domain?
We're gonna
Vertical asymptote?
One.
Okay.
Well, we can't
So-
say that yet, because we don't know, or well, we
it might be
can.
whole, you don't know.
can.
1 minus 3 plus 2 plus, oh. yeah,
Well,
okay.
we can tell if this is a factor of that.
Yeah, but it's.
Yeah.
Remember how the factor theorem?
Point
From,
one.
you just plug in the 1, and 1 minus 3 plus 1 is not equal to 0, so is it a factor?
No.
No, so since it's not a factor, we can say it is a vertical asymptote.
If it was -1 that you're plugging, like, if it was x plus 1 on the bottom, would you plug in a -1?
Yes. Yeah, you would. Okay, so we do have a vertical asymptote. So if we want to graph that in, we could. It's probably not going to be straight.
It's kind of tilted, right?
All right, good. All right, horizontal asymptote.
It reaches infinity at both ends, or one of the infinities.
Okay, so
Have to start.
none. Is that what you're telling me?
Yes.
All right. All right, slants.
Yes.
Is there a slant? Okay, find the slant.
Oh.
Find the slant.
Why is just not telling me?
It's gonna be that one.
It's never enough.
It's gonna be
It's never enough to sit here and say
Quadratic, you are
I
correct.
know.
Because he told me.
Why is there like all of them?
I do.
By looking at it. So the Q is automatically.
Oh. Well, if these aren't your favorite, then like, what is your favorite?
That's like it.
Oh, you did say they're your favorites?
X squared minus 2x plus 1.
All right, why do we ignore that last little part? Why do we ignore the remainder?
Because it's not one.
Because it's
It's not because it's not the
to
quotient.
Because as that a remainder, when we look at that, we think about towards positive infinity and towards negative infinity.
These are really bad.
It becomes what?
Obsolete.
0. Yeah. Yeah. And what do the asymptotes help us with? Yeah. That in behavior. All right. So we got this.
Wait, so that's not, so that would be the exact formula of the asymptote, but we kind of just don't use it for.
All right. Yes, you can do it that way. Because the asymptotes are telling us what's happening at positive and negative. All right, so what does this factor to? x minus 1 squared. That's really kind of nice because we know how to graph that parabola. Oh, no, we don't. There we go. Now we do. I put it on 1 now. So the vertex is at 1. It's just a regular old parabola, so I got normal moves.
So it's not slant.
Well, no, the asymptote's got the
Parabola.
asymptote, so is it even an asymptote?
That is a good question.
That's not the question.
Wait, so it says slant asymptote or parabola?
This is an oblique or slant, yeah. That's how we would classify this.
Oblique twists.
Wait, how do you
Alright, so,
But now we need to find zeros.
yeah, let's find some zeros. You are going to need
A calculator.
a calculator to find your zeros. So I would take the numerator, punch it into y1, and locate your zero. Go ahead and do that. The signs are what is messing up that ability to calculate.
Oh, it's.
If that one were negative, it would.
Yeah, that's what we'll do that.
Is the one negative?
Oh, it still would fire.
If,
Yeah, it would. Yeah, it
if the
would. But
one
it would
was
factor the X.
negative, it's the same thing as negative.
I'm a little confused on how we find those zeros for the numerator.
You gotta punch in your calculator into y1 and actually do the left bound, right bound with your zeros.
So we would need the calculator.
You would have to have the calculator.
Thank you.
Guys, if I put this on a no calculator part, I would have to give you this.
Zero?
Yeah, I would have to.
Yeah, because it's.
Could you tell us if we need our calculator for that?
I will give you some that are no calculator and some that are calculator.
James, I just write it off for long.
2.259, but it's 2.99,
Yeah, you're quite.
so about 2.60. Okay, so right, obviously right there. Okay, what about a y-intercept?
How do you calculate that?
Zero. 1.
Plug in 0 right here, and everything but 1 over negative 1 goes away. So it's going to be 0, negative 1. All right, sign chart. Sign chart, and then I should be good.
Well, we already graphed it. Can
Oh,
That's kind of cheating. All right, what's the only thing?
one.
And
One and
We got,
negative 0.6.
okay? And so over here it's positive, down here it's negative, and over here it's positive. So if it's positive on this side, it's going to ride along this asymptote. If it's negative over here, it's going to ride along that asymptote. And then over here, it is positive, which means it rides along this asymptote, and it rides along this asymptote, and I don't know where that is. Okay? Now, I can actually find that point, that local min, with the calculator. Yes, sir.
When it says positive, it means positive for
Positive means it's above the x-axis. That's what a positive means. This part of the graph is above the x-axis because that's where your y values are positive. Negative means this part of the graph is below the x-axis, above the x-axis. That's what the positive and negative, that's where the y values are positive and negative, and that puts it either above or below the x-axis. Jonathan and then Vic. On this one, because I noticed this was a perfect square trinomial, I knew how to factor it. So then this put it in vertex form, where the opposite of this is my x, and what's added to the end is my y. Yeah? Ben?
Oh, never mind.
Okay. The other day, the way we found the vertex is we did negative b over 2a. To find the vertex of a parabola, x equals negative b over 2a gives you that x coordinate at the vertex of a parabola. Of a quadratic. Alright, so the backside of yesterday's 2 problems is what we're going to start now.
Is that HW?
That is HW. Your HW is on the back of yesterday's 2 probs.
What's back
Okay? We do have a quiz on Tuesday. So keep that in mind. Make sure you're working for understanding and not just for completion.